Like and subscribe my channel, you hobbit.
Dude, is it me or is Rust going crazy? It's crazy. Rust this, Rust that. Man, you're a moron if you use Python. Whatever. It's been a little weird lately, so I've been getting on a Rust bandwagon a little bit. Yeah, I've been messing around with it for a month, two, whatever. Something like that. Maybe a little bit more. So I saw a bunch of stuff on LinkedIn. I think Noah on LinkedIn. Noah Gift on LinkedIn. Go follow him. He's pretty good. Puts a bunch of content out on Rust. He was talking about saving a ton of money using Rust for your Lambdas instead of Python, which I get. I have a lot of Pythons I run at work that are processing fairly large files many times a day, like fairly large files, like millions of records files. And I thought I would kind of test it out in my personal AWS account, see what happens. Just take basically a flat file that is fixed width. If you know what fixed width is, I hope you know. If not, Google it and convert it into tab. It's like a common use case, right? Some very large fixed width file and you need to convert it to tab or some other comma separated whatever pipe, so it's easier to ingest downstream. And obviously Python uses a lot of memory, right? And it's slow. We all know that. I use Python every day. It could get expensive with a Lambda, so it just made me think like how much memory savings and what would be the performance increase switching from Python to Rust using a Lambda. So I thought I'd just give it a shot. It's an excuse to write some Rust, so it should be pretty interesting here. Okay, so for making these Lambdas, I'm just going to use the console, AWS console, right? I'm just going to go in and set up two Lambdas, just empty Lambda, one for Python, one for Rust, just leave them blank. And then obviously you could do this with a CLI, but just for ease, I'll just create two blank Lambdas in the AWS UI, two blank Lambdas, and then we'll just write the Python code, which I've already written. I'll show you. We'll walk through it, and then we'll do the same thing with Rust. I'll basically convert the Python into Rust and kind of walk through it, hopefully doing the same thing. You know what? What's the name down here? It's like average engineer, right? I'm not that good, so be nice. My Python's mediocre Python. My Rust is horrible, but that's how you learn, right? Okay, so hopefully you know what a AWS Lambda is. You live under a rock. Come on. So my Lambdas are going to be triggered off an S3 file. So I already mocked up a fixed width file. I just took some hard drive open source data from Backblaze hard drive. They got some website. They got like free. I'll leave a link. They got free data you can mess with. I just downloaded one of their CSV files. I converted it into fixed width, just to like reproduce what that would look like. I'll show you that here. And then basically what we need to do with this Lambda is when the file hits S3, it's going to be gzip, by the way. It's going to be this .txt. You could call it .txt, .csv, whatever. It's a flat file, fixed width. It's going to be gzipped. When that gzip file hits the S3 bucket, it'll trigger the Lambda, the Python, the Rust, and then they'll process it and rewrite out, right? So read in the file, converts the fixed width to tab, delimited in this case, and then gzip it again and push it back out into S3. So that's kind of the process. Okay, let's walk through this Python code. So if you don't know anything about a Lambda, basically any Lambda starts with a Lambda handler. You can change it, but like default, any code you write in a Lambda, you just, you write a function called Lambda handler, and that's where, that's what the Lambda is going to default. That's what is going to would be called by the Lambda runtime, right? It's going to call that. So here, let's talk about this, right? So here's my Python code. You can see down here I have a defined function called Lambda handler, and if If you're new to Lambda, just go to like the AWS docs. They got all sorts of examples. Just go there and you can like take their code and just replace. That's why I just copy and pasted their code and they just placed it inside. Okay, so what are we going to do in Python? Boto 3, we make a Boto S3 client. Obviously, when the Lambda kicks off, it could have more than one event coming to it, right? If you drop more than one file, so we're just saying for record in event records. And in our case, this is going to be a file hitting a bucket, because that's the trigger for Lambda, right? We just pull the bucket name and the key name. So the bucket's just the name of the bucket in AWS, and then the key is the name of the file, including directories, even though there's no such thing as directories on S3. Did you know that? Anyways, so now we have that. And we're going to download that file, right? So let's go look at this function. Download takes the client, the bucket, the key. We're just going to read into memory, bytes.io. Just download the file object, right? So we make a file object, the bytes.io, just S3 client. Let's download that file to that object, and we seek it back to the start. I don't know if I need to do that, probably. And then return the file object, which is our file. Right? Super simple Python. That's why we love it, man. Read memory file, because it is a memory file. What did I do? Okay, read memory file. All we're doing is just, remember it's gzipped, right? So we just gzip open file object, read lines, boom, right? Really easy. Basically have to unzip it and read that file in one big memory object. So we have the data. We just make a empty list called tab rows, right? Because, well, everything here is fixed width, that data. So we're just going to say for row and data. Then we'll convert each one of those rows from fixed to tab. How do we do that? We just come in here and I guess I should have shown you this. So like here's our fixed width. Here's our columns, right? Data starts at 0, goes to 15, serial number 15 to 36, blah, 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 model. All these are different. That's fixed width, right? From this position to that position. Well, I think it stops before there, like up until 15. All right, so that's all we're doing. We're saying for each of these items, so for each one of these, data, serial number. So for each row, we pull out, we have an empty string, right? It's just row, empty string. So for each one of those items, so for each date, serial number, model, capacity, failure, we pull out of that raw row. We just slice into that string, right, with those indexes that we have up here. So from 0 to 15, now you have date, and you just append it onto that row. Yep. And we tab limit, right? So every time you get that raw value, that column value, you just add it into row, take the white space out, and just add a tab, because we're going to tab delimit it, right? So now we have that actual value, the white space, tab it, and the new line at the very end, return it. We just do that over and over and over again, right? And we take that tab rows and we just append it there. And then, so once we're done with that, rows to file object. By the way, I think there's like 230,000 rows in this test file. We just write, I know we could do it in memory, but whatever. We're just writing to the temp location on the, storage for the Lambda. Just write this gzipped file. So we open a gzip file and write all the lines that we just converted. Of course, the last thing we do is just upload it, right? I mean, it's easy. Just upload the client, S3 client, upload file, blah, 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 bucket. We just replace the tab gz and just put in a different spot, right? Fix. Now we're tab converted. Easy peasy, lemon squeezy. And we can actually go look at the results in S3, in our console, AWS console. We can go look at the logs and see how long it took for that Python script to run. We can see that it's about 8.362 seconds for that to run. So 8,361 milliseconds, which is about 8.362 seconds, and it took about 139 megabytes of memory to do that work. 230,000 records. Okay, so quick and dirty, let's do this in Rust. Like I said, my Rust isn't that good. Whatever. Okay. Again, we have a handler, an async handler in Rust. It takes the Lambda runtime, That's what we're using. Use Lambda runtime. It's a nice AWS provided crate. It's the same thing. It'll look similar to the Python, right? So just at a high level, we've got events coming in, right? And they're JSON, so we can just from JSON value get that request, unwrap it. Makes sense, right? So we have events just like before in Python, and so we're gonna just loop those events for event and events records. We're gonna loop that. We're gonna do the same thing, right? It looks almost the same so far in Rust. It's really nice, right? Bucket, name, key, pull it from the event. Just like in Python, right? And what do you know? It's easy again, right? We got to download that. It's a little bit more verbose, right? In Rust, obviously. We make a AWS config, make a client, pass it the config, blah, blah, blah. Data. Now this is where we actually read the bytes down into memory. So from the client, we get the object, bucket, key, send, await, unwrap, body, collect, await, unwrap, into bytes. Seriously, Rust, async. It gets whatever. It works, right? Hopefully it's fast. If you've not seen Rust, it might look a little async Rust. It might look a little weird, but that's kind of like what the await is doing. Then unwrapping that, making sure there's no error, getting that result, the okay result, body, collect it, await it again, unwrap it into bytes. So now we have basically the same thing in Python. Right now we have our basically bytes of the data, of the gzipped, right? Don't forget that, the gzip data. Next we make what's a crate called? It's called flate2 crate. That's a decent one to use for like gzip encoding, decoding. So we make a decoder using that data. And then, right, because it's bytes, we want to convert it to a string. So we make an empty, mutable CSV data string. And then we read that decoder. We read to string. That's what provides us that nice read to string. We can pass it our empty string, mutable string, and unwrap it in there. Boom. Now we have CSV data is going to have all our, fixed width string data in there. What do we have to do? We got to split the lines. Split it on new lines, right? Dot lines. Boom. Get your new lines. Get your lines. Come get your lines. Step right up. And then collect it, because now we have a vector of strings that we can basically loop through, right? That's what we want. A vector of rows, right? Each line or lines, right? That are fixed width. Let's make a blank tab converted string. This is where we're going to push. Kind of the same in Python, right? We did the same thing. So now we're going through the vector, which is just like a list, whatever. It's what it is. Vector. And then, so we're going through there, and then we do the same thing, right? It's a little bit more verbose, right? So we got to pull out each one of our, what do you want to call it? Yeah, we're slicing into that string. I don't know if that's the right wording. We're using the indexes. Same thing, right? 0 to 14, trim it. So we have this line, right? We're looping through. The line is fixed width. So go in there, slice into that, pull the date out, trim it. Same thing, serial number, slice in, trim, blah, 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 right? And then we just use this nice format. I don't know. Is there a better way to do this in Rust? It's like string concatenation usually, right? So I'm like tabbing. Look at that. Curly braces, tab, blah, 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 new line at the end, and then we just lay in our values that we took out. Now we have a tab line. Wow, I don't know. And we have our tab converted, new string up here, and we just push that string to it. Right? I think that's a good way to do it. I don't know Rust, man. Okay, so that's pretty easy so far, right? So now we have that. What do we need to do? We need to write it to a file. So we open a file. We gzip file name, tab converted, right into it, right into our file. So we take all that data and we write it in to that compressed file. Write all, buffer, tab converted as bytes. So let's write it in there, and then we finish it. I don't know. It's just like how gzip does it. You finish it. I don't know. And then, so we just wrote the file. Now we got to open it and read it again. That makes sense, right? Open the file, read it, and it's a little bit different because we need my phone's going crazy. So we have a file. We need to open a buffer and read everything in there, because that's what is going to be required by AWS to upload it again. So basically reading back that gzip file, reader, read to end, buffer, and now we have a remote URI. We're just changing where we're putting the file, and S3, put the object, bucket, key, the body. There's our buffer, the file, and we send, await, unwrap, boom, files in there, done. What's up, Rust? Welcome to me. Look, I know that Rust was probably painful to read for Rust people, but I'm learning. So now we get to look at the Rust results. And what do we find in the CloudWatch logs? Turns out that Rust uses about 85 megabytes of memory, which is like a lot lower than the Python. Like way lower than the Python, right? What was Python, 130 or something like that? 139 megabytes, and the Python the Rust is 85 megabytes, so way less memory, like 40% less memory. I mean, that's cheaper, right? I think they charge you based on how much memory you use, right? But the overall runtime is 6.452 seconds, 6,491 milliseconds. That's not as, it's like 22% faster than the Python at 8 whatever seconds, but it's like 22%. I thought the runtime would be like, I don't know, kind of like memory, right? It uses 40% less memory. I thought Rust would be 40% faster. I'm not sure if it's probably because of my Rust. I don't know. Maybe I'm doing something wrong with the Rust. Could be. I'm sure somebody who knows what they're doing could increase that, right? But that's not nothing. If we think about what we're being charged for in a Lambda, the duration and the memory, right? Reducing memory by 40%, runtime by 22%. That's not nothing, especially if you're running this all the time, right? You're running Lambdas constantly on large millions of records, right? This is only 230,000 records. It's not that much. It still took, a decent amount of time. Even Rust, it took longer than I would have thought. So imagine if you're processing 5 million lines or something. You could save some serious money probably using Rust, and it's not that much overhead, really. The building, I don't really talk about that, but like if you install the crate Rust Lambda, I think it's called Cargo Lambda. No, Lambda, Cargo Lambda. Yeah, it's a crate called Cargo Lambda. Install that and you can run a couple command line like Cargo Lambda build release. Zip, it like puts out a bootstrap zip binary file that we upload. Just FYI, it's interesting. Yeah, the Rust is a lot of extra code. Looks like it's faster and uses less memory. I don't know, and it wasn't like horrible to write. It was kind of fun. Is it worth it for data engineers? Should you switch? Yeah, if like you're trying to save money and you want to do something cool and learn Rust, yeah, definitely get rid of all your Python. But the problem is data engineering, man, it's just all Python. Everybody's writing Python, and do they want to write Rust? Maybe they want to, but are they going to learn it? That's not insignificant to bring a new programming language into any stack, right? Because it's not just writing. Now you got to learn how to unit test that. You got all the CI/CD writing. You need Docker files now to like run automated tests and builds. And I guess it's just not nothing. If you work at a startup like me, sure, it might be easier just to bring it into your stack, get away with it a little bit, do a little minimal effort to bring it on. But, you could sell it with the cost savings. I'd have to go look. I don't know. I mean, you could probably like actually calculate, 40% less memory, 20% faster, how much that's going to save me in money. I don't know how that, yeah, whatever. Yeah, it'd just be interesting. But Rust, yeah, hopefully I can keep working on it. It's not that bad. I hope you guys that don't write it could see that code just was not it was readable. You could see what was going on. Even if you've never written it before, you could follow it easily. Granted, I didn't have anything in functions and stuff like that, but yeah, like and subscribe, please, or I'll send somebody to find you. I'll write like a Rust thing, come like, I don't know, take your Wi-Fi down or something.